All right, let's work some examples. So on the handout that was provided to you, take a look at number 3. Well, with number 3, we're given our triangle, and we are told that, here we have A, B, and C, and we're told that, well, if I label them correctly, this is C and this is B. I have A, B, and C, and I'm told that angle C is 96 degrees, A is 6, B is 4, and we have to solve for the measure of angle A, the measure of angle B, and side little c. So if you use that process that was given to you, then the very first thing I'm going to do is I am going to use the law of cosines to find little c. So I have little c squared is equal to, I'm going to have a squared plus b squared minus 2 times a times b times the cosine of 96. And so just to simplify this down just a little bit, this is going to be c squared is equal to 36 plus 16 is going to give me 52. And then I'm going to subtract 2 times 6 is 12, times 4 gives me 48, times the cosine of 96. Now once I'm here, because I'm solving for my c, I need to take the square root of both sides. So I have the square root of 52 minus 48 times the cosine of 96. And I'll let my calculator do all of that fancy legwork. And so this is going to give me c is approximately equal to, it says to round your lengths to the nearest tenth. So we are approximately equal to 7.6. And then it goes on to say you need to use the law of sines in order to solve for your missing angle measures, or for one of them. So if you solve for the side opposite if you solve for the angle opposite the shortest side, then we're going to solve for angle B. So when I use the law of sines, I'm going to have 4 over the sine of B is equal to 7.6 over the sine of 96. And so from here, I'm going to cross multiply. And so I have 4 times the sine of 96 equals 7.6 times the sine of B. I'm going to divide both sides by 7.6. So right now I have the sine of B is equal to 4 times the sine of 96 divided by 7.6. And then because I'm solving for the angle, I'm going to use the inverse sine of 4 times the sine of 96 divided by 7.6. And then when I'm here, I let my calculator do all of this fancy legwork. So I have the inverse sine of 4 times the sine of 96 divided by 7.6. And this gives me the measure of angle B is approximately equal to, and it says to round off to the nearest degree. So this is going to be 32 degrees. And then in your 3-step process, what you're to do is you're to take 32 and 96 and the measure of angle A with your triangle inequality theorem. And so what I know is that the measure of angle A plus the measure of angle B plus the measure of angle C all have to add to 180. Well, I'm looking for the measure of angle A, but I know that the measure of angle B is 32 and the measure of angle C is 96 as given to me in the problem equals 180. So the measure of angle A is going to be 180 minus 96 minus 32. And so this gives me 52 degrees. So you have 3 pieces of this triangle that you've solved for. The measure of angle A, you solve for the measure of angle B, and you have solved for your side length, little c. So the next one, number 5. Here you're given all 3 sides instead of 2 sides and an angle. So with all 3 sides, we have, here's our triangle A, B, C, and we know that B is 8, A is 6, and C is 8. Okay, so you're going to want to very badly use the Pythagorean theorem with these, but you can't use the Pythagorean theorem unless it's a right triangle. So that's where our law of sines and cosines comes into play. So the first thing I'm going to do is I'm going to use the law of cosines to solve for angle A. And so to solve for angle A, I'm going to have A squared, which is 6 squared, is equal to B squared plus C squared minus 2 times B times C times the cosine of A. So this gives me 36 equals 64 plus 64 minus 2 times 64 is going to give me 128 times the cosine of A. So this gives me 36 equals 128 minus 128 times the cosine of A. Now the number one mistake that students make is they attempt to subtract these two, which you can't do because this 128 is being multiplied by the cosine of A. So these two are not like terms. You can't subtract them. All I can do at this point is subtract my 128 from 36, and this is going to give me negative 92 is equal to negative 128 times the cosine of A. And then I divide both sides by negative 128. And so this is going to give me positive 92 over 128 equals the cosine of A. And I can further simplify that, but it's not necessary because now that I'm solving for my angle, then the measure of angle A is going to be equal to the inverse cosine of 92 over 128. So the measure of angle A to the nearest degree is approximately equal to 44 degrees. Okay, now I have a couple of different options at this point. I can repeat the same process for one of my other 2 angles, or I can use the law of sines. The law of sines is quicker, it's more efficient, so I always revert back to the law of sines if possible. So what I know now is that the measure of angle A is 44 degrees. So I can say, if let's say I want to solve for the measure of angle B, well, I know that 8 over the sine of B is equal to 6 over the sine of 44. So I have 8 times the sine of 44 is equal to 6 times the sine of B. I divide both sides by 6, so I have the sine of B is equal to 8 times the sine of 44 over 6. And then to solve for B, I'm going to take the inverse sine. So the measure of angle B is equal to the inverse sine of 8 times the sine of 44 divided by 6. And I let my calculator do that fancy legwork. So the inverse sine of 8 times the sine of 44 divided by 6 is equal to about 68 degrees. And then to solve for angle C, the measure of angle C is going to be 180 minus 44 plus 68, which is going to give me 112. And so the measure of angle C is 68 degrees.